When you're doing hypothesis testing, there is a big difference between things that are statistically significant and things that are practically significant. So here's an example. Researchers want to test a new medication that claims to raise IQs to genius levels. And when I say genius levels, I mean like 175 plus, incredibly high. In the population, the average IQ is 100. A sample of 40 individuals that has taken the medication has a mean IQ of 110 with a standard deviation of 15. So it looks something like this. The null hypothesis is that the mean is 100 because we would assume them to have a mean of 100. And the alternative hypothesis is that the mean is different than 100. We're testing to see if the mean is different from the 100 we would expect. So let's say we do that, a t-test is performed and we end up rejecting the null hypothesis. So we're going to say, okay, we're going to conclude that the medication raises IQ. Now doing something like this, the whole rejecting of the null hypothesis and saying the alternative is true, that is called statistical significance. By rejecting the null hypothesis, we have found statistical significance. But now realize that the medication claimed to raise IQs to genius, like 175 plus levels, and in this case, the sample mean was 110. So even though we found statistical significance, the medication did not really meet the practical value that it claimed to. I mean, sure, it raised IQs a bit, but the difference between 100 and 110 is nowhere near the difference between 100 and 175. That's incredibly different. So even though we found statistical significance, it lacks practical significance. This medication, it didn't really do what it said it was going to do. So that is statistical significance and practical significance.